Over the next couple of class periods, our goal is to continue thinking about what the derivative tells us about the graph of our function f. So we'll consider both what f prime and what f double prime tell us about the function f itself. So we've kind of talked about the fact that critical points come from the first derivative and tell us information about absolute maxes and mins. And today we'll look at what the derivative tells us about where a function is increasing and decreasing. And so before we connect this all back to derivatives, let's just think about in general, what does it mean for a function to be increasing and what does it mean for a function to be decreasing? And so let's draw an example of an increasing function. So you might believe that something like this is increasing. As we move from left to right, the y values are getting bigger. What I like to think about this is if I hike, we always go from left to right as x values increase. So if I hiked along the graph, I'd be going up if I'm working on an increasing function. So this whole function is increasing. We can look if I take two x values, then we notice that the y value at the bigger x value is bigger. So increasing means that f of x2 is, well, let's actually write this in the other order. F of x1 is smaller than f of x2 if x1 is smaller than x2. So the y values get bigger as the x values get bigger. Okay, so this is what it means for a function to be increasing. A function is decreasing, really, if we have the opposite thing happening. So this is an example of a decreasing function. So again, if I walked along this graph from left to right, I'd be going downhill on a decreasing function. And so our inequality is going to work backwards here. If the x value gets bigger, then the y value gets smaller. So f of x1 is bigger than f of x2 if x1 is less than x2. Okay, so those are kind of like ways to write what it means to be increasing and decreasing based on the original function. But let's think about what the derivative looks like on an increasing function or on a decreasing function. So on this increasing function, we notice that the slopes are always positive. So the derivative is always positive. And on this decreasing function, we notice that the slope is always negative. So the derivative is always negative. So what it's going to mean is that a function is going to be increasing when its derivative is positive and will be decreasing where its derivative is negative. And we can have functions that are both increasing and decreasing at various places. So something like this would be increasing. Whoops, let's do the same colors as I did before. Increasing up to here, increasing over here, and then decreasing in the middle. So a function can have periods or have intervals where it's increasing and then different periods where it's decreasing. So maybe let's put some numbers on here. So we could say that this function is increasing on the interval from -1 or from negative infinity to -1 and on the interval from 2 to infinity. And it's decreasing on the interval from -1 to 2. Notice that I'm putting parentheses around all of these, which means that those endpoints are not being included. Because if we look at -1 or at 2, the tangent line is horizontal at both of those places, so the derivative is 0. And the derivative being 0 is going to mean that the function is neither increasing nor decreasing. It's kind of pausing for just a second before it changes direction. Okay, so this is the increasing and decreasing test. So if the derivative is positive on an interval, then f is increasing. If the derivative is negative on an interval, then the function's decreasing. So the way that we are going to use this is we're going to have to figure out where is the derivative positive, where's the derivative negative. So let's look at what we're going to do here. So this problem here is asking us, where is this function increasing? Where is it decreasing? So the first thing we're always going to do is take a derivative. So the derivative in this case is 6x squared minus 6x minus 12. We can go ahead and factor a 6 out. We're left with x squared minus x minus 2. And then let's go ahead and factor that. That's x minus 2 times x plus 1. Okay, so what we're going to need to do here, this is like our first step is find the derivative. Our second step is going to be find the critical points. If you look at that previous example, the critical points would have been the -1 and 0. Those are the places where the derivative changed signs. So those are going to be important values for us. So in this case, our critical points are places where the derivative is 0. So that will be -2 or +2, sorry, and -1. Okay. And so now what we're going to do is we're going to create a sign chart. So what we're going to do is we're going to put our two critical numbers on here, making sure to put them in numerical order. I'm going to label this with f prime because everything on this sign chart is coming from the derivative. And so now what I need to do on this sign chart is I need to say, if my x values are less than -1, what sign does the derivative have? So if I plug in my favorite number less than -1, you can really pick any number. I like -2. I'm going to plug it into the derivative. So if I plug -2 into the derivative, 6 is positive. -2 minus 2 is negative. -2 plus 1 is negative. So I get positive times negative times negative. That whole thing is going to be a positive. So I'm going to put a positive on that sign chart. Okay. Now I'm going to do the same thing. I'm going to take a number between -1 and 2. 0 is a good choice. If I plug x equals 0 into the derivative again, 6 is positive. 0 minus 2 is negative. 0 plus 1 is positive. When I multiply that all together, I get a negative sign. Okay, and then I'm going to pick, again, a number bigger than 2. My favorite number bigger than 2 is 3. Again, plugging that into the derivative. And I like to plug things into the factored form of the derivative. So 6 is still going to be positive. 3 minus 2 is going to be positive. 3 plus 1 is positive. So I get a positive out here. Okay, so what this tells us is that if x is less than -1, my derivative is positive. If x is between -1 and 2, my derivative is negative. And then if x is bigger than 2, my derivative is positive. And so now we're going to like interpret the results. And you don't have to write these like steps as a 1, 2, 3, 4. I'm just giving this to you for the first one. So f prime is positive if, let's see, on the interval from -infinity to -1 and the interval from 2 to infinity. So that's where f is increasing. And f will be decreasing where the derivative is negative. So f is decreasing on the interval from -1 to 2. Okay, again, noticing that I am making those open intervals. I'm not including any of those endpoints because at -1 and at 2, my function is neither increasing nor decreasing. Okay, interestingly, I think I probably graphed above the function that we're working with here, and that was totally coincidental. -1 and 2 are not always our critical numbers. Okay, so we'll get lots of practice with this in class.